The next section in 3.6, or the next subject in 3.6, is inverse variation. Okay, so as y varies inversely as x, or y is directly proportional to x. And then the same is true when we talk about inverse variation as the nth power, just like direct variation, right? So you can have the nth power of x, or the second power of x, or x squared, or the square of x. Sometimes they might say, instead of this, they might say the square of x, so that means x squared, right? Or the cube of x. Those two usually are used, pretty often. But once you get past cube, usually it's the nth power. So those are ways for inverse variation to look. So we'll do a couple examples of these as well. So basically, what this is as one variable increases, the other one decreases, because here's how it's written. This is written as y equals k divided by x. So it's always equals k, but this time we're dividing by x. So here, as one increases, right, as x increases, as x gets bigger and bigger, isn't y going to get smaller and smaller? All right, so say if our k is 1, so y equals 1 over x, which, haven't we looked at this before? This is our reciprocal function. F of x equals 1 over x. So direct relationship. That's why this variation's in this subject, because here we have our reciprocal function when k equals 1 or anything, right? This direct inverse variation. Okay, so as x gets bigger and bigger, like 1 over 2, that's a half, right? 1 over 4, isn't that 0.2, 0.25? This is 0.5, 1/8, 1/16. So as x gets bigger and bigger, isn't my number getting smaller and smaller and smaller? So as one increases, one decreases. Where direct variation was, as one increases, the other one also increases. Okay, so inverse variation is as one increases, the other one decreases. The nth power is just written like this: y equals k over x to the n, right? And n could be any power there, any integer there. So let's do some examples. Okay, so here's one. If y varies inversely as x, and y equals 10 when x equals 3, find y when x equals 20. Okay, so it's always equals k. Even though we're doing inversely here, it still starts out with always y equals k. Now, what comes before the word varies? That's y, so y becomes before the equals. The next word that follows is our operation. It says inversely, so inversely is division. So we're going to divide, and then whatever comes after inversely, that's going to be in the denominator then, because inversely is division. So we're dividing by x, so x goes in the denominator. Now we can go ahead and go to step 2, right? Plug in our values. Y is 10, x is 3, so put y is 10 and x is 3. Now we got to solve for k. Second part of step 2. So we multiply by 3 on both sides, get rid of that denominator. 3 times 10 is 30, so our k equals 30. So k equals 30. Now we can move on to step 3, plug that back into our original equation for k. Now we can go to step 4 and solve for any additional information. Now they want us to find y. Well, when do they want us to find y? Well, when x is 20. So we're going to plug 20 in for x. We're going to plug 20 in for x, so y, let's do it over here, y equals 30 over 20, which is 3 halves, right? 1.5, so y equals 1.5. So y equals 1.5 when x equals 20. So there's our answer to that. Okay, so here is an example. So here's an example. We're finding if in a company, and you're producing something, your items cost a certain amount, right? And it costs so much to make those items, and that's what this is talking about. The cost of producing a single item varies inversely as the square of the number of items produced. So how many items I produce will impact how much an item costs, right? So the more items you start to produce, the less the cost is going to go down. Okay, and we'll definitely get in more the thick of this in calculus when we start talking about marginal marginal cost and marginal revenue and stuff like that. We'll just kind of go over the basics here. But the more items you produce, the less it's going to cost, right? Because you could say you could start buying in bulk, right? If I'm making a single item, if I start buying in bulk, like it's cheaper to buy in bulk, so then I can produce this item at a lower cost. There does come a certain point where if you make too many items, then the cost actually increases, and we'll talk about that more in calculus, but we're just looking at this inverse relationship here between the cost of a single item, so this is the cost of a single item, right? And so cost of the single item, we're here, and we're comparing that to how many number of items produced, okay? So the first sentence in all these word problems is pretty much how you can write your equation. The second sentence deals with actually finding your K, and then the third sentence usually deals with, okay, if you do this thing, what will this be, right? Your fourth part of the equation, or your steps. Okay, so here we're going to write our equation, right? We're talking about numbers of items produced, and you can see that in the second sentence. If 100 items are produced and each costs $2, so here we could, by the second sentence, we can find our variables, right? We have items and we have cost, right? So we have items and we have cost. So it's always equals K, right? So we put equals K. Now what becomes before the varies? Well, here's varies. What comes before? An item, right? So that's I. So I equals K, and then it says what word follows the varies? That's our operation, right? Inversely, so that's dividing, so K divided by. And what follows that inversely? What thing is it talking about? It's talking about the number of items, so the number of items produced, okay? Oh, so that would be our I, sorry, that would be our I, and because before varies is single item, but the cost of that item, so this needs to be C, right? And actually a lot of people can solve this without even actually writing the equation, right? They just think about it in their head, and they have kind of a math mind where it figures it out. They're still doing math, but they just might not know they're actually writing this inverse variation equation in their mind, and they're doing it. So you can usually set it up by proportions as well. Okay, well anyways, let's get back to fixing this. So equals K, right? It starts out as equals K. What comes before varies? Well, that's the cost of a single item, the cost, right? So that'd be C equals K, and then what follows that is inversely, so that's divided by, and whatever comes after that, the number of items produced, so that's our I. So our I is down here, but what type of I? It says the square of I, right? The square of number of items produced, so that's I squared down there. So now we have our formula. Now we can solve for K. Second sentence is going to give us our C and our I, right? Here's our I, here's our C, cost and items, right? So the cost is $2 and our items is 100. So now I got to square 100, right? So that's 1 times 1 and then 4 zeros. So that's 2 equals K over 10,000, right? And then how do I solve for K? I multiply both sides by 10,000 and I get 20,000 over here, right? So K is equal to 20,000. Now I can go ahead and plug in my K, which is step 3, right? So C equals my K, 20,000 over my I squared. Now I can find out what the cost of any item, right? So as long as I plug in my I here, I can find the cost of any single item, right? So if we put 400 in, that's what they ask for. So C equals 20,000 over 400 squared. So that's just 4 squared and add 4 zeros. So C equals 20,000 over 16 and 4 zeros. So that's 160,000, right? So we can cancel out some zeros here, right? So there's 4, we can cancel out those 4, we can cancel out these 4. So we get 2 over 16, which is 1/8, and 1/8 is 0.1 0.125, yeah. 0.125. So it's going to cost about 12.5 cents, right, to produce these. Okay. But you kind of think about this. That's why if I produce 1,000,000 items, then my cost is going to be 0. It's still going to cost me, right? So that's something to think about, like for later in calculus. Just because if I produce that many items, then the cost is going to be 0. Well, your operations cost is going to start, turning on the lights, turning on the machines, electricity. That kind of adds into this stuff, right? All those stuff kind of add into actually the cost of the item, not just your materials, right? But actually the machinery, the labor, electricity, power, stuff like that. Goes into the cost of the item. So there reaches a point where if I make too many items, my cost actually starts to increase because I got to pay for more labor force, I got to pay for more electricity and stuff like that. So there comes a point where you want to only produce a certain amount of items. I don't want to produce too few, and I don't want to produce too much because I want to maximize my revenue, right? I want to maximize my profit in there, and that's where we get into marginal cost, and that we'll get into in calculus. We might speak about it later on a little bit, but definitely in calculus. Okay, so I'm going to do the homework problem for you, and then this video will be done. So page 366, number 31, we're going to work on that one. And I'll type that up for you, and we'll start working on it. Okay, so here's the problem, right? Number 31 for your homework. An electric current flow, right? So that's just setting the scenario, so we don't need that information. It's just setting the scenario. It is found that the resistance offered by a fixed length of wire given a material varies inversely as the square of the diameter of the wire. And then you can read the rest of it. But this first part is going to set our equation, right? It's always equals K. So this is always equals K. Now what comes before the word varies? So look at the word varies, and we're going to have to look all through this, right? It is found that the resistance of resistance offered by a fixed length of wire given a certain material varies inversely, right? So the length of the wire of a certain material, so this stuff, all that matters is this length, right? Length varies is the square of the diameter, right? So we have resistance, we're going to look at that resistance, and we're going to look at the length of the wire and the diameter, right? So we're going to look at resistance because it's the resistance offered by a fixed length of wire. So they're going to give us a resistance, and we can look at the second sentence and the diameter that we're really comparing. Okay. And we can see that in the second sentence. If a view of 0.01 inches in diameter, right? So a diameter has a resistance, so that's where you can tell in the second sentence really what your variables are. You have diameter and resistance. Okay, those are the two that we're going to be comparing because those are the two numbers that they give us, right? They give us a diameter and they give us a resistance in ohms. Okay, and then we want to know, okay, what is the resistance if we have a wire of the same length, because it has to be a fixed length, right? So that fixed length has to be the same in both scenarios here. That's why it says the same length down here, because if we have a different length, the resistance might be different, right? And then a diameter of 0.03, we want to find what the resistance is. Okay, so what comes before the word varies? That is resistance, right? So resistance, so we can be R. And then what comes after the word varies is going to be, our first word is going to be the operation, right? Inversely, so that's K divided by. And then what follows that? Well, it's the square of the diameter. So that's the D squared, diameter squared. And you can use any letters for these. You can use Y and X, it doesn't matter. Okay, so now we got our formula. Now we can enter in our information. Resistance of 0.4, so 0.4. Okay, over our diameter, which is 0.01. So we got to square 0.01, so take 0.01 and times it by itself, and that will give us 0.001. So 0.001. Oh, there's another 0 in there. 0.0001, 3 zeros. Okay, and over k equals 0.4. Then we multiply by 0.0001 on both sides. 0.0001 times 0.4. So k is equal to 0.00004. So there's our k. And now we want to go ahead and find out, plug that in, right? Step 3 is to plug that into our equation. So resistance is equal to 0.00004 all over our diameter squared. Now they're going to give us our diameter, step 4, and the diameter that they say is 0.03. Come back up here, 0.03, yeah. So 0.03 squared, and we're going to divide that by our 0.00004, and that's going to be our resistance. So we take that number, 0.0004, and we divide that by 0.03 squared. And that gives us a resistance of 0.04. Okay, so that gives a resistance of 0.04 and ohms, right? And nearest 10 thousandths, right? Oh, 10 thousandths. Okay, so I got a 10 thousandths. So it's actually, because this is 10 place, this is hundredths, thousandths, 10 thousandths. So we need to go out a little farther. So it's actually, if we get our calculator out and we divide that again, we get actually 0.0444. So that is our in ohms, right? In ohms. So that's the problem there. Done. Okay, well first I'm gonna do a couple more problems with that. Let's go back here. Here's a couple more just for extra practice. If y varies directly as x, right? So what comes before it's always equals k. What comes before varies, that's y. What comes after, that's our operation directly. So multiply what follows that, x. Now we can plug in our y and our x. So 9 and 30 divide by 30 on both sides. So this is a direct variation, right? 9/30ths, which you can reduce those by 3. So 3 over 10. So y equals 3 over 10. You could do a decimal if you want to. You can just do it to the tens place or hundreds place is fine. Okay, and then we can enter in our x now because we want to find y when x is 40. So we plug in 40. 40 over 10 times 3, right? I'm just kind of rewriting that. It would look like this, right? 40, because I'm dividing by 10. So it doesn't matter if I take 3 divided by 10 or 40 divided by 10 first, right? And so that's going to be 12 is our answer. Okay, here's an inverse, or here's jointly. I think I already did the inverse one. So that's fine.